Alright, now that we've done a few questions from exercise 3A, I'll just be going through some more complex operations with surds. The questions relating to these questions I'm about to do are further down in the exercise 3A, which are question 5, 6, 7, 8, and 9. All there is just A, B, C, D questions of all of these questions I'm about to do just now. Okay, so let's look at the first example of a more complex kind of question. So it says simplify 2 root 75 minus 5 root 27. Firstly, what comes to mind is that you can simplify 75 as 2 root 25 times 3 minus 5 times 9 times 3, because 9 times 3 is 27. Now you can see that square root 25 is just 5, so you can write that as 2 times 5 times square root 3 minus, you can see that square root 9 is just 3, so you have 5 times 3 times root 3. So all you get is 5 times 2 is 10, so you have 10 root 3 minus 5 times 3 is 15, so you have minus 15 square root 3. 10 minus 15 is 5, so you have minus 5 root 13. If you want to practice these kind of questions, you should do questions 6A, B, C, D, E, F from exercise 3A. So you can do question 6 in exercise 3A. Now the next example I'll be going through is this. So it says to expand and simplify. So expand and simplify. So the question is root 5, 6 minus root 5. So from what you know in expanding, all you do is you expand root 5 with 6 and root 5 with root 5. So what do you get when you do that? You get root 5. Actually, let me do that in a different color. So you have root 5 times 6 plus root 5 times negative root 5. So what is root 5 times 6? Well, that's just 6 root 5. And then now you have 5 times negative root 5. So square root times the square root is just a number. In this case, it's negative. So you will have minus 5. That's the answer. You just multiply, you expanded, and we simplified, and you have 6 root 5 minus 5. If we were to do questions like these, do question 7 from exercise 3A. And question 8. Question 8 involves more than 2 surds, more than 3 radicals. So question 8 is good to get a better understanding of how these work. Now we will be going through the next subtopic, B, division by surds. Alright, so what does this mean? Division by surds are basically numbers such as, let's say 6 over root 2. This is a number that involves division by a surd. Now, what the main thing is when you have a division, a surd which has a radical at the denominator, is that you have to simplify and rewrite this number so that the denominator does not have a square root. because that is just how it works. So this process is called rationalizing denominator. All you're doing is multiplying the number. All you're doing is multiplying this number with the same number as the denominator. Now that might be a bit confusing, but all you're doing, so for example, in this number, we have root 2 as a denominator. To rationalize it, all you're doing is multiplying this number with root 2 over root 2. So in this case, you have root 2 times root 2. That just becomes 2. So now you do not have a square root in the denominator, and the top just becomes 6 root 2. This process is called rationalization. Rationalize the denominator. If you ever see a surd with a denominator has a square root, always rationalize it like this. This is the basic process of it. Let's look at a quick example question. Okay, so you have the question. So it says write with an integer denominator. Integer denominator is the same thing as just having a normal number as a denominator. So the question is 6 root 5, and we have to rationalize this. All you do, square root 5 times square root 5, and this just becomes 6 root 5 divided by 5. This is how you rationalize something. Let's look at another one. 35 divided by root 7. So again, you're rationalizing this, so you do times 7 divided by times root 7 divided by root 7. So now you would have 35 root 7 divided by 7. But you can actually cancel out 35, as 7 times 5 is 35. So you have that as 1. You have this as 5. So your final answer would be 5 root 7. That is the process of rationalizing. You always have to do this, and it becomes easier later on when you have to deal with a lot of numbers at once. Now that we understand what rationalizing is and how you do it, take a moment and do these 5 questions from exercise 3B. Exercise 3B has many more questions. I have just taken 5. So if you have the PDF or the textbook, go ahead and try to do every single one. Take a moment, pause the video, and do these questions. Alright, now we'll be going through these questions. So first one, pretty straightforward. Root 3 divided by root 3, which just gives you 3 root 3 divided by 3. 1 over 4 root 2. Again, this is pretty straightforward. You have root 2 in the denominator times root 2 times root 2 equals root 2 at the numerator, and then you have 4 root 2 times root 2. Root 2 times root 2 is just 2, so you have 4 times 2, which is just 8. 15 over root 5. Again, root 5 divided by root 5, which is just 15 root 5 divided by 5. Now you can actually see that you can cancel out and simplify this even further, as 5 times 3 is 15, which is just 3 root 5. Next one, 2 root 11, straightforward. Root 11 divided by root 11 is just 2 root 11 divided by 11. 1 over square root cubed. Now again, if it's squared, you times it twice. If it's cubed, you times it thrice. So what this basically means is 1 divided by root 3 times root 3 times root 3. Now you know that root 3 times root 3 is just 3. So all this basically means is that it's 1 over 3 root 3. Now you go on to your normal rationalizing process. Root 3 divided by root 3. So you have root 3 in the numerator, and that's root 3 times root 3. Root 3 times root 3 is just 3. So 3. So you have 3 times 3 is just 9. So your answer is root 3 over 9. Now, exercise 3b has many more questions. Go ahead and try to do that. Alright, now we move on to the next subtopic C, which is exponents. Now, let's say, for example, you have 2 times 2 times 2 times 2 times 2. So you have 2 times 5. Well, this is a bit tedious to write and it's just very long. So instead of just writing this, we can write this as a product. So you write this as 2 root 2 to the power of 5. What this means is that this number right here is the base. This is the number that is being multiplied 5 times. And this right here is called the exponent or power or index, whatever you want to call it. Usually exponent and the power. This is a number that determines how many times the base is being multiplied. This number is the base. So 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. That's all this is. And you would pronounce this as 2 to the power of 5. So that is all that exponents is. Just a quick note on a simple trick that you can use is that, for example, let's say you have let's say you have negative 1 times 1. Well, negative 1 times 1 is just negative 1 to the power of 1 is just negative 1 because you're not actually multiplying by anything. But let's say you have negative 1 to the power of 2. That is negative 1 times negative 1. So you're multiplying a negative number by a negative number, which becomes positive. Then, let's say in the next case, you have negative 1 to the power of 3. You do the same thing, negative 1 times negative 1 times negative 1. You know that a negative times a negative is a positive. So you have this as 1. But you're again multiplying it by a negative number. So that just becomes negative 1. Let's look at one last case. Negative 1 to the power of 4. That is negative 1 times negative 1 times negative 1 times negative 1. So this can be written as 1. And this can be written as 1. 1 times 1 is 1. Do you notice a pattern here? Every time you multiply a number with a negative base, so a negative number, with a odd power, so for example odd as 1 and 3, you're getting the negative answer, a number in negative. And every time you're multiplying it to an even power, 2 and 4, you're getting a positive number. So from this, just keep in mind that keep in mind to save time, negative base to the power raised to the, odd power, so an odd number on top, the power, is negative. And the same goes for positive. A negative base to the even power, so the even number, so for example 2 and 4, is positive. This is a handy trick that may come in useful at times, but it's just important to know that there is a pattern actually being in use and being in place. Okay, so after the pattern, I recommend that you guys do exercise 3C. So do exercise 3C, because exercise 3C has many questions regarding exponents, listing the powers, and writing a number as a power. I'm not necessarily going to go through them because I think they are fairly simple. But if you guys have any questions, you can put in the comments, of course. But I think they're fairly simple. So I will be skipping through exercise 3C. And I will be going on to part D, which is about the laws of exponents. So part D, laws of exponents. All right, so what can we say about power laws? So as I mentioned before, exponents have different types of power laws which you can follow depending on different things. Okay, so the first law I will be telling you guys, so actually let me just write number 1. So the first power law, exponent law, is when you have something like, let's say, a to the power of m times a to the power of n. Well, what does this mean? Here you have a number with a power multiplying by a number with a power. So the law states when you have this kind of question, the powers add together. So you will have a to the power of m plus n. So when you have a number with a power with another multiplying with another number with a power, you add the power. So let's say if you had powers such as, so example, if instead of m and n you had 2 and 4, you would just add 2 and 4. That is all the first law says. To multiply a number with the same base, keep the base and add the exponents. Again, base is this, keep the base and add the exponents. So that's the first law of exponents. Second, we will look at when you have something, let's say a to the power of m divided by a to the power of n. What does this mean? Well, this law states that when you have a base with a number with a power divided by a number with a power, all you're doing is subtracting the powers and you're keeping the base. So it's kind of, in a way, opposite of this. Here you have multiplies, so you add them. Here you have divides, so you minus them. So to divide the numbers with the same base, again base, which is a, keep the base and subtract the exponent. So for example, let's say you have m as 4 and n as 2, and all you're doing, so your answer would just be a to the power of 2. Oh, whoops, a to the power of 2. That's all the second law says. Now the third law, when you have something like a to the power of m in a bracket times n, this whole number to the power of this exponent. That is what this thing says. Here the law says when you have something like this, all you're doing is multiplying the exponents. You have a to the power of m times n. You have a number which is something to the power of something to the whole power of something. So in numbers, this could be like 2 to the power of 2, and the whole thing is to the power of 2. And all you do is multiply the exponents when you have, so an easy way to remember this is when it's like this, you just remember this is times that. Just draw like an X on the bracket. That's how I remember it. So you have a to the power of m times n, which is the fourth law. Third law. Fourth law is when you have something like a to the power a, b to the power of, let's say, n. What does this mean? When you have a power of a product, you have product of the powers. Now this means that when you have, so this is a product, a times b, to the power of n. So all that happens here is the n goes to a and the n goes to b. So you will end up with a to the power of n times b to the power of n. You're giving the power to each of the numbers in the product. That's all the fourth law says. Similarly, the fifth law, if you have a over b, whole thing to the power of n, it's the exact same thing, a to the power of n divided by b to the power of n. And again, n goes to a and b. And just remember that here, b cannot equal to 0 because 0 cannot be in the denominator. So the power of a quotient is the quotient of the powers, if that makes sense. Sixth law is when you have something to 0, something to the power of 0. Ignore what I said. Something to the power of 0. All this means is 1. This is what something to the power of 0 is defined as. For example, 2 to the power of 0 is defined as 1. Anything to the power of 0 is defined by 1. Is defined as 1. Keep in mind, a cannot equal 0. Seventh and the last law is when you have a to a negative power, a to the power of negative n. Well, usually we don't deal with negative powers. To make a negative power into a positive power, we divide the whole thing by 1, and then that becomes a to the power of n. So that is what all this means. Anything to negative power, divide the whole thing by 1. Just keep in mind that if you, for example, this can also happen in reverse. 1, let's say you have 1 over a to the negative power of n. This is just simply a to the power of n. Bring this to the top instead of 1, and then that will become a to the power of n. So just remember these two things. Both can happen. Both can happen. So these are the 7 laws of exponents that you should understand. I'm gonna go find some questions now, but it's good if you understand these laws, because these laws happen everywhere, wherever you have exponents. So it's good if you understand them right now. Alright, now that we actually understand the laws of exponents and how to apply them, do these 9 questions, pause the video, and come back for the answers. Okay, so firstly, before I start solving them, these are from exercise 3D from the textbook, the IB Mathematics Core Topics SL1 textbook. So now let's do question 1. Question 1, simple. K to the power of 4 times k to the power of 2. That's referring to the first law. So that is k to the power of 6. You're adding 4 and 2 to get 6. Next one, 11 to the power of 4 times 11 to the power of a. Again, you are applying the first law right here, the first law. And so you have 11 to the power of 4 plus a. This is the answer, because a is an unknown. You don't really know what a is, so you can't add it to 4. It doesn't become 4a. So the answer is just 11 to the power of 4a. Next one, c to the power of 8 times c to the power m. Again, same thing, c to the power of 8 plus m. You can't really add m to anything, it's an unknown, so you get a plus m. Here you have 3 things, but the law remains the same. The first one, you have r to the power of 2 plus 5 plus 4, which is r to the power of 11. Next, we have 2 to the power of 4 times 2 to the power of negative 2 times 2 to the power of negative 1. Now, you may be tempted to use this 7th law right here, but that is not what you do. This is just simple. It's applying the first law again. All you get is 2 to the power of 4 plus, and then in brackets minus 2, and then you have times -1. So after you do this, let me just move that here because I don't really have space. After you do this, you know the 4, you know plus and minus just becomes minus. So this is basically 2 to the power of 4 minus 2. So when you get 2 to the power of 4 minus 2, you get 2 to the power of 4 minus 2 minus 1 because of this other one. So you have 4 minus 2 minus 1, which is just 2 to the power of 1, or you can just leave it as 2. Number 6, k to the power of, I think I wrote 12, yeah, I think it's 12. Let me just write that better. K to the power of 12, yeah, okay. Over divided by k to the power of a. You're using the second law here, the division one, where you subtract the exponents. So all this is k to the power of 12 minus a. Again, a is an unknown. You don't really know what a is, so it's just 12 minus 8. Next is x to the power of 3a. I think, yeah, 3a divided by x to the power of 2. Again, this you're using the same law. You get x to the power of 3a minus 2. There's not much you can do after this. 3a is just a number minus 2. This is all you do. Next we have 11 to the power of x to the power of 2y. So you may recognize this. This will be law number 4, where you're splitting the power exponent to each of the bases as done here. So the same thing goes here. 2y would go to everything. So this just goes to 11 2xy to the power of 2xy. And lastly, w to the power of 7p divided by w. Well, this divided by w, we can just rewrite this as w to the power of 7 over p, 7p, I mean, divided by w. And you know that w is just w to the power of 1, or w1 if in any case is just w. So this just becomes w to the power of 1. So applying the law, you get 7p minus 1. Check how many you got right. If you don't understand them, put in the comments. Redo them if you don't get them or got them wrong. But these are fairly simple. I've just taken very few questions from exercise 3D. There are many more questions, so I recommend you do those questions just to get a very, very good understanding and a base of what exponents, how the laws of exponent work. I will now be going over some example questions of different kinds of questions you get when you get questions of laws of exponents. So first example question. Okay. So the question says, write, okay, I'll actually write them. Write as a power of 2. So the question is, write 16 as a power of 2. So, well, as a power of 2, so what is 16 divided by 2? Well, it's 4. So you can just do that in other words. That's just 2 times 2 times 2 times 2. Now, what you learned from before is that this is unnecessarily long. You can write this as 2 to the power of 4 because you're multiplying 2 4 times. Okay. Question B is 1 over 16. Again, same thing. We just did what 16 was. So we can just write 1 over 2 to the power of 4. Now, we don't really want this to be as a fraction. It's just a bit tedious. So when you bring it up, you apply the inverse law. I mean, when I say inverse, it's the opposite of this law. You have something as a something here. So you're using this part. So you have 2 to the power of 4 over 1. When you bring this up, this becomes this. So when applying that, 2 to the power of 4 going up becomes 2 to the negative 4. C. write 1 as a power of 2? Well, we know that anything to the power of 0 is defined as 1. So, well, this is just 2 to the power of 0. Simple. Now, actually, let me just bring that there and bring this there. I'll just be doing one more. So you have 4 times 2 to the power of n. Well, you know that 4 can be written as 4 is 2 times 2, which is written as 2 to the power of 2 times 2 to the power of n. So applying the first law, you can add the exponents, so you'll just get 2 to the power of 2 plus n. So to do questions like these, I recommend you do questions 5, 6, 7, 8 from exercise, from exercise 3D to do questions like these. Now, the next example question, that looks like an A. Next example question, and let me just actually bring that there so everything is just organized. So it says express in exponent form with a prime base number. Prime number base, prime number base. And the first question is 9 to the power of 4. Well, what can you actually write as a prime number? Well, you know that 3 is a prime number. So you can write 9 to the power of 4 as 3 to the power of 2, because 3 to the power of 2 is 3 times 3, which is 9. And because you have a 4 here, you put the 4 outside. Well, this looks familiar. This is kind of like a law we had before. Now, you have a 3 to the power of 2 to the power of 4. So you now just get 3 to the power of 2 times 4, which is 8. You have to decide first what the prime number base should be before attempting a question like this, because it asks specifically for a prime number base. To do questions like these, I recommend doing questions, question 9 from exercise 3D. Another different type of question you might see. Again, that looks like an A. So it says write without brackets. Just simply write the number without a bracket. Write without bracket. Excuse my bad handwriting. So the first question you have is 3x to the power of 3. Again, this looks familiar. You have something to the power of 3 in a bracket. Now, because this is in a bracket, the 3 goes to the 3, the power 3 goes to the 3 and the x. This would get you 3 to the power of 3 times x to the power of 3. Now, you know that 3 to the power of 3 is just 3 times 3 times 3, which is 3 times 3 is 9, 9 times 3 is 27, so you have 27x to the power of 3. And now you have written this as, written this without a bracket. It's another quick question, just for the sake of it. X divided by y to the power of 4. Again, this is in the form of a over b to the power of n, where n, in this case 4, goes to x and goes to y. So you have x to the power of 4 divided by y to the power of 4, and that is all you do. So to do questions like this, do question 10 from the textbook, exercise 3D, question 10. And for now, these should be enough types of question that you will see. I recommend that you just do these questions that I've stated, these questions, just to get a hang of these questions, and then you will be able to actually apply them later on. Okay, now that we know the different type of questions when dealing with laws of exponents, I think it's a good time to go over the last part of the chapter of surds and exponents, which is part E, scientific notation. Now, this part is extremely crucial as scientific notation is used everywhere in every other subject, mainly sciences such as physics and chemistry, and you'll see them in math, physics, chemistry, everywhere if you study them, if you plan on studying them later on. Okay, so what do I mean when I say scientific notation? Well, it basically involves writing any given number as a number between 1 and 10 multiplied by a power of 10. Okay, so it's basically any number as a number between 1 and 10 multiplied by by power of 10. Okay, so what do I mean by what? Okay, so in numbers form, what this means is that any number between 1 and 10. So that means, okay, so let me just first write down what this looks like. So any scientific notation looks like a number times 10 to the power of anything, let's say k. Now a can either be 1 or less than 1, greater than 1 or equal than 1, equal to 1, or has to be has to be less than 10. So this means a can take the form of 1, 2, 3, 4, 5, 6, 7, 8, and 9. These numbers are all a. You can't get anything greater than 10, and you can't go less than 1. And this becomes useful because you have extremely large numbers such as 1 million, 10 quadrillion, anything like that, because you want to write them as a short, easy way because it's just very tedious. Okay, so let's look at a example question, and let me show you how you write something as a scientific notation. So example question. So it says write as scientific notation, expressed in scientific notation. So we have to write 37,600 as scientific notation. Okay, so the trick to writing any number as scientific notation is to imagine that the decimal point is at the last of the dot, is after the last number. So you have a decimal point here. Now, you know that a has to be a number between 1 and 9. So the trick to doing is you have to move the decimal place to the first number. So count how many spaces. So it goes 1, 2, 3, and 4. So it takes 4 times to get to 3. 4 times. So now you would write 3, 7, and 6 as 3.76 because you've moved the decimal place here, making this 3.76. And because you've moved this 4 times, you multiplied by 10 to the power of 4. So this is scientific notation. Let's just check if this matches the form. Well, you have 3.76. 3.76 is between 1 and 10. 1 and 10, yeah. And you have times 10 to the power of 4. 4 in this case equals k. So now you have written something like a number like this in scientific notation. You're shifting the decimal point 4 places to the left, and you're multiplying it by 10 to the power of 4. We're multiplying it by 10 1,000. Let's look at a different case, which is the only case you'll see. So these are only two cases. Let's say you have 0.00000086. How do you express this in scientific notation? This is also very easy. Just a few things are different. Let's say you have something like this where it's a small number. So basically, now you have your decimal point here. All you're doing is moving it again to 8. So you go 1, 2, 3, 4, 5, 6. You move the decimal point towards the 6 places to the right, and you have the decimal here. So how would you write that exactly? So now you have 8.6 times 10 to the negative 6, because you're basically dividing it, because you're going from, because this is a small number. So the trick to recognize whether it's a negative or a positive is that okay, let me actually write this so you guys understand. So when the decimal point goes towards the left, the answer is 10 to the power of positive number. And when the decimal goes towards the right, your answer will be 10 to the power of a negative number. This is all that scientific notation is. You're writing big and small numbers into a short form with a power of 10, and it has to follow these main laws. Now, I think it's, for the time being, I think it's very, very crucial if you understand what is a negative and what is a positive power of 10. When the decimal, let me just say again, when a decimal goes towards the left, you have a positive power of 10. When the decimal goes towards the left, you have 10 to the negative number to the power of 10. This is all scientific notation is. So we have any number as any number between 1 and 10 multiplied by a power of 10. A can only be 1 to 10. So it's important that you understand this, and it's important that you understand these two example questions. Okay, just before starting these 10 questions, let me just clarify something. When you guys start using scientific calculators or any calculators, whenever it says, for example, let's say 2.7 times e to the 10, e is just a easier way of writing 10, because scientific calculators are not that big, so they can't really contain that many numbers. So they just write e as 10. So just remember that e is always 10 in a calculator, or even in your phones if they have it. Okay, now we've clarified that. Try these 10 questions and pause the video and come back for the answers later. Okay, I'm assuming you guys have done the questions now, so we have to write these numbers as a scientific notation. So first one, 259. So it's very simple. Imagine the decimal point is here, so you move it 1, 2. You move the 10, you move it twice, so you have 2.59 times 10 to the 2. Write that better. Times 10 to the power of 2. Because now you move decimal place there, so you have 2.59. Now, 270,000. You have the decimal point here, so you're moving it 1, 2, 3, 4, 5. Oh, 5. So now that you move the decimal point to between 3 and 7, you get 3.7 times 10 to the... Wait, 1, 2, 3, 4, 5. I lost track. My bad. Okay, yeah. So you have 3.7 times 10 to the power of 5. Now, this massive number. Again, these are the kind of numbers you're going to deal with in math, in different topics, and physics as well. So here you have a decimal point here. So you have 1, 2, 3, 4, 5, 6, 7, 8. Oh god. Okay, we're going to do that again. But it was 6. Say from here is 6, 7, 8, and 9. So now that you move the decimal point between 2 and 5, you get 2.59 times 10 to the power of 9 because you moved it 9 times. So next we have 0.000259. Now you're moving the decimal to the left. Sorry, my bad. You're moving decimal point to the right. So you move it 1, 2, 3, 4. This is the first number. So 2 is the first number. So you have 2.59. And because you moved it to the right, you have 10 times 10 to the power of 1, 2, 3, 4. Negative 4. That is the answer. Just another quick question. 0.00, so you have 0.000089. Again, now you know that 8 is the first number. We don't really need to move your decimal point for that unless you want to. Times 10 to the power of 1, 2, 3, 4, 5, 6. So that would be negative 6. How many? These are the answers to these 5 questions. Some of them are from exercise 3E. Some of them I just made it up. But most of them you'll find from 3E. Now it asks us to write as an ordinary number. So you have 5 times 10 to the 2. So what does that mean? You basically have 5 times 0 times 100 because it's to the power of 2. 10 to the power of 2 is 100. So all you're doing is moving decimal points. You're doing the opposite. So you move decimal place 1, 2. So you have 500 as your answer. 7.8 times 10 to the 4. Again, you have now 7.8000. Now you move it 4 places away. So you have 1, 2, 3, 4. So your answer is 78,000. 4.33 times 10 to the 7. This is going to be a big number. Okay. Oh, okay. So you have 4.3300000. So now you're moving it 7 decimal points away. So you have 1, 2, 3, 4, 5, 6, 7. Just to make sure we have 7. That is 433 million. 43 million actually. So you have 1, 2, 3, 4, 5. 5 zeros. Next is 4 times 10 to the negative 3. So now you're doing the same. You're writing as the opposite number. Instead, now you will have. Well, you're moving it the other way. So you have 10 to the negative 3. So basically, you would have 0004. Imagine decimal places here. So you're moving it 1, 2, 3. You write 3 zeros because it's negative 3. So now you know that you move a decimal point there. So as an ordinary number, this is 0.004. Yes. And the other one, this is going to be a big number again. So you have 4.33. So let's write that. But now you have negative 7. So you have 1, 2, 3, 4, 5, 6, 7. That was not okay. And then now you're moving it to the first number because you want to write as an ordinary number. So you have 1, 2, 3, 4, 5, 6, 7. We have 7. So that would be 0. So the ordinary number would be 0.00000043. And these are the answers to these questions. I recommend you do whole of exercise 3E because there are a bit more questions involving scientific notation, and it also involves calculators and also a few word problems. And just like that, this is the end to part 2 of Surds and Exponents. We have now finished chapter 3 of the IB Core SL textbook. Just to clarify, this is everything we've done. We have done surds and other radicals, division by surds, exponents, laws of exponents, and scientific notation. I will try and make this whole sheet available if you guys need it, but I recommend you doing maybe not every single question, but do as much as you can. And as a review, I recommend you doing review set 3A and review set 3B. So So review set 3A and 3B, because review set will be questions from every single topic every single of the 5 topics we covered. Hope this video was helpful to you guys, and next few chapters will be coming out very soon. Thank you, and post any questions you have in the comments. Thank you.